Here is a video model to explain how to draw the Bohr-Rutherford model of the atom. So grade 9 science, all levels can use this type of ABA. So let's do a little review, just a really quick one here. Protons are positive and they're found in by taking the atomic number. Where is that, Biddy? That is in the periodic table of the elements, the top, the smaller number in each of the boxes. What are the electrons? They are found by using the same number, the atomic number, and they are negative in charge. And the neutrons are neutrally charged, which means they have no charges at all. And that's found by the atomic mass minus the atomic number. So let's take a look at sodium here. A sodium has an atomic mass of 22.99, rounding up, remember, would be 23. And that is all the stuff in the nucleus of the atom, which are the protons and the neutrons. So subtracting the protons out of the atomic mass will get you your neutron number. Sometimes the neutron number is different, so you can't always use the same number all the time. So let me explain. All right, so we have, let's do sodium just for fun. So we have protons, and taking a look at the periodic table, we don't have to do any guessing a lot of the times in science. So the atomic number is 11, so there's 11 protons. How many electrons? It's going to be the same number. And the neutrons are, excuse me. We're going to subtract the big number from the small number, I like to say. So 23 minus 11 equals 12. I like seeing that math to know that you understood how to get there, but if you don't do it, I'm not going to cry about it. All right, so the Bohr-Rutherford model of the atom is created by putting your nucleus stuff in the center. So all you have to do is put the P's, 11P, and 12N inside. Now, floating around the atom, like I said, using this model that we use with our hands, you can see that we have electrons floating around. So they're called orbits. So the orbits are found on the outside of the atom, outside of the nucleus. And the first orbit can have 2 electrons. Then the next one can have 8, and the next one can have 8, and the next one can have 18. So we usually don't go too much farther than that. We go up to 20 in grade 9, and then you learn a different model in grade 11. So for the first orbit can take how many? 2. That's right. So we're actually going to do them in not little e's, but we're going to do little dots for e's. And then the next orbit we're going to draw, we'll have the rest of them. So we'll have up to 8. So let's do 8 first. And I like to pair them to make them look pretty. And it's easier for Miss Bidwell to mark when it comes time for me to mark. So now we've put 2 and 8 on electrons on. So how many do we have left? We have 1 left. So we actually have to make another. It's good that we're starting with a big one, so you can see. So just double checking before you ask if it's right, or just to make sure. I will check for one that you think isn't right. I will check one for you, but I will not check your whole assignment. So let's take a look. 1, 2, 4, 6, 8, 10, 11 electrons. So we use the third orbit to put the last electron on. All right, so when we get to your assignment, you're gonna make a bunch of them. Look at them. So when you get to this part of the assignment, you're going to look at the periodic table for more than half of this assignment. How cool is that? So SI, you're gonna look for the SI symbol, which is right here. It is silicon. So we're going to put the information about silicon using the periodic table of elements right there. So let's take a look-see here, shall we? We've got silicon is 14, and it's spelt. Okay, and then the atomic mass will go here. There's an information page that comes with it, but I like to model a whole bunch of these, at least the first 3, so they get a good idea. So the protons, how are we going to find that? It is the atomic number. Yay! The atomic number of silicon, we actually wrote here, 14. So you can take that number and put it right there. You don't even have to do any work anymore using the periodic table of elements, if you remember that rule. The electrons are also the same number. What? Right there. And then we have the neutrons, which are neutral, and we have 28 minus 14 equals 14. So if you don't want to do the math, you don't have to, but you take this number and subtract it by this number. So there's the blue there. All right. And then, how do we know if it's solid, liquid, or gas? Well, I'm taking the guesswork out for you, and I'm going to tell you right now that it is a solid. So you're going to put a little colored in dot for solids there. And then we're going to, I usually start with the nucleus because it's small, but it's memorable. So how many neutrons? We have 14. How many protons? We have 14. And we have the fiery red electrons of 14. So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then how many more do I got left? Oh, I got 4 left. So 1, 2, 3, 4. I just spaced them out to look pretty. As long as they're in pairs, at least I'll accept them. You don't have to. I just want to make sure that they're easy to read for you. Generally, it is in pairs. And then this little thing down here, there's a little table that tells you what color to color it. So Si is red, so you're going to shade this in red. When you cut them out, you're going to see that you have to make this way better than me. Like, that is a challenge. You're going to have to color this in. I know it's not coloring class, but you got to color it in and make it look good, all right? It's a visual learning tool. And then for this model, you're just going to be showing the valence electron, which is the outside electron, which is only the 4. Doot, 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 doot. All right, and we are done one of these things. So that, you can watch this again and again to make sure that you know what you're doing. And I color-coded it to make sure that helps, that you can see the difference. I showed you where everything came from. And of course, if you have any more questions, I am here for you.